All right, so this is a video for an introduction into what we'll be doing tomorrow. So I have a couple of examples that we'll look at here. Tomorrow during our block, or next time I see you during our block, is going to be mainly a practice day where we're just going to do a ton of practice graphing sine and cosine curves. But I have these two examples here that are a little bit more difficult than what we were doing in class to help prepare us for that, and then we'll talk some more about some together, and then we'll do some practice for the rest of our block period. So the other day we were talking about, or today in class we were talking about sine and cosine curves. Talked about the general shape of them, and then all we really were able to talk about in class today was amplitude and the letter b, which helps determine the length of the period. Today I'm going to talk about shifting these graphs side to side and up and down. So, if you'll recall from class, here are the standard forms for all sine and cosine curves. Sine a times the sine or the cosine of b times x minus h plus k. All right. So we just talked about already how A helps determine our amplitude. B helps us determine the length of our period because we learned that P is equal to 2 pi over B. And then today we're going to add in, or in this video, I'm going to add in H values and K values. Remember that H values shift us left or right, and then K values shift us up or down. We learned about these earlier in the year when we were talking about transformations. And so the same rules are going to apply here, although these are kind of tricky as we do these because there's some steps that you have to make sure that you keep in mind as you run through some examples that have these. So first and foremost, or first of all, we're going to try this example here. Okay. And I'm just going to tell you, I purposely made this one kind of a tricky one to show us some good fraction work. So what you'll notice is this function has a -5 at the front. Okay, so that means the furthest distance that our graph is going to get from the middle is 5. The b value here is 6. So if we wanted to do this right off the bat, we could. The period is 2 pi over 6, which would be pi over 3. So we know that the length of one period of this graph is pi over 3. But what we're adding in that we didn't see during class is this graph has a shift of right pi over 9, and it has a shift of up 2. All right, so here's how I like to start all of these. Sometimes I don't even do this part until after I've done what I'm about to show you right now. Here's how I think about this. If this number out at the front is a -5, that means normally the highest that this graph would go would be 5, and the lowest that this graph would go would be -5. However, everything in this graph gets shifted up too. So what I'm going to do instead is I'm going to say, all right, if the highest that this usually goes is 5, but it gets shifted up 2, now the highest that this goes is 7. And if the lowest that this goes is normally -5, and it gets shifted up 2, well, now the lowest that this goes is going to be -3. The other thing that I always like to do on these is I like to say, hey, the new middle of this graph, instead of being at 0, like it would be in a normal sine and cosine graph, it's now at 2. And I like to put a little dashed line right here to represent the middle of the graph. So what this tells me is if I'm going to put a point in the middle of the graph, I have to put it along this dashed line right here. Okay. Now, the other thing that I'm going to mention is that, or the other thing I'm going to mark down before I start doing any sort of calculations, is that normally a sine or a cosine curve would start its first period at 0, but this got shifted to the right, pi over 9. The reason why it gets shifted to the right is because this is a minus sign and not a plus sign. So instead of putting my first mark at 0, what I'm going to do is I'm going to put a mark right here, and I'm going to label this pi over 9 because this is where my first period starts. Okay? All right, from here we can start doing some calculations. And I know this is going to seem like a lot, but as you start to understand the process of this, you will realize, hey, it's just the same thing over and over and over again. Let me get my vertical axis labeled. Let me get my beginning mark labeled on the horizontal axis, and then I can start thinking about the length of the period, where the period ends, and everything else. So let's go back here. I already calculated this, and again, sometimes I don't do this until after I've already labeled all the stuff that I've labeled. But the length of one period of this is 2 pi over b, and the b value was 6. So I went ahead and plugged that in here. So 2 pi divided by 6 simplifies down to pi over 3. Now, number one mistake. See, people make this mistake all the time. They come over here and they say, all right, the length of the period is pi over 3, which means this ends at pi over 3. This is wrong. Do not do this. Okay? If the period started at 0, it would end at pi over 3. But you have to remember that this period started at pi over 9. So instead of ending at pi over 3, what we have to do here is we have to say, all right, and I like to sometimes do some calculations off to the side. I started at pi over 9. My period has a length of pi over 3. So where's this thing going to end? Well, if I add these together, I got to have a common denominator. Common denominator here would be 9. Okay, so pi over 9 plus 3 pi over 9. That means this period is going to end at 4 pi over 9. So I'm going to go ahead and label that here. Period ends at 4 pi over 9. Okay, so we got my starting value. I got my ending value. We're almost done. We just have to label the stuff in the middle. We've learned that, hey, what we do with these is we cut one period into 4 equal parts. The reason why we do that is because there are 4 quadrants on the circle when we look at our unit circle. So I'm going to put those 4 marks right there, and we need to label all 4 of these marks. A little trick I taught you guys yesterday. What I like to do is I like to say, all right, if the length of the period is pi over 3, each piece, or in other words, each little section right here, 1, 2, 3, 4. Well, if this total length is pi over 3 from the beginning to the end, each piece has to be whatever pi over 3 times 1/4 is, because that's what that means is I'm taking the period and I'm cutting it into 4 equal pieces. So that means each piece has to be a pi over 12. Okay. Again, huge mistake that I see students make. They put a pi over 12 right here. That's wrong. If we started at 0, then the next piece would be at pi over 12. However, we started at pi over 9. So if I want to find the next piece, what I'm going to have to do is pi over 12. Sorry, let's say starting at pi over 9, and I have to add pi over 12. Okay, so I'm going to add pi over 12. Now, as I mentioned a second ago, I made this one tricky on purpose. The common denominator between 9 and 12 is 36. So I'm going to make this one 4 pi over 36. And then this one's going to be 3 pi over 36. So this is 4 pi over 36 plus 3 pi over 36. The very next piece of this period has to be at 7 pi over 36. Okay. And then from here, I'm just going to keep adding a pi over 12, which again is a 3 pi over 36. So 7 pi over 36 plus 3 pi over 36 is 10 pi over 36. Okay, if I add another 3 pi over 36, I get 13 pi over 36. And then if I add another 3 pi over 36, I get 16 pi over 36. And let's check this out. This should match up exactly with what I have as my ending piece right here. Let's try it. If I divide 16 by 4, and if I divide 36 by 4, 16 divided by 4 is 4 pi, and 36 divided by 4 is 9. So this seems to check out right here. Okay. Now we could leave it like this if we want. You might notice that 10 pi over 36 simplifies down a little bit. That simplifies down to 5 pi over 18. However, if you left it at 10 pi over 36, I would be fine with that. But if we're just looking at this here, this is 4 pi over 36, 7 pi over 36, 10 pi over 36, 13 pi over 36, and 16 pi over 36. So the top of these go up by 3 as the bottom stays at 36 the entire time, and then I just simplified some of these fractions a bit. Okay, this is the hardest part of the graph. From here, all we got to do is we got to make sure that we graph this appropriately. So this is a sine graph. You learned in class that all sine functions start in the middle. So I'm going to put my first point right here in the middle. Notice that I'm not putting the point over here on the y-axis. I'm putting it instead right here because this graph got shifted to the right, pi over 9. Okay, so I'm going to start in the middle. And then if this graph is negative, like this one is, the first place it's going to go is down. So I'm going to go down to here, back to the middle, up to the top. I'm going to finish where I started, back in the middle. Okay, and then I can connect all my points, and I'm finished with my graph. And remember in class we said there's a bunch of questions I could then ask you about this graph. We'll save some of those until we get to class, and we'll try an example, and then we'll ask some of those follow-up questions. But this is the general graph right here. So basically what this is telling me is that if I plug in any of these values that I've plotted right here into my original function, I'm telling you the answer that I'm going to get when I'm done. So if I were to plug in pi over 9 into this equation, or into this expression right here, when I'm done, I would get a value of 2. If I plugged in 13 pi over 36 into that expression and simplified it all down, I would get a value of 7, and so on and so forth. Okay? All right, one other example here. Let's see what we can do with this one. I'll make the numbers a little bit nicer on this example. So let's try, let's go g of x equals 7 times the cosine of pi over 50x plus pi over 25 minus 3. Okay. Now, one thing I want us to notice on this, if we think about a normal cosine graph, okay, in the standard form, here's what the standard form would look like. So what I want us to think about for a second is this thing in standard form? And what you'll notice here is this is not, because in standard form, the inside of this has some parentheses, and right here, we do not have any parentheses. So what we're going to have to do to get this thing into standard form is we're going to have to factor. So when you look at one like this, if it's not in standard form, the very first thing you must do with this is you must factor out the b value that's in front of x. So here's what I'm going to do. I'm going to rewrite this as 7 times cosine of, I'll leave everything else the same, but on the inside, I'm going to take out this pi over 50. Now my job is to figure out what's left over on the inside when I take out this pi over 50. I know for sure the very first thing I'm going to have is an x. Now the thing that students have a lot of trouble with is figuring out, well, what's this number over here? So I'm going to give you a really easy way to think about this, okay? You don't have to do this when you're multiplying and dividing fractions, but this is the one time where I think that this is a helpful trick. What I can do with this is I can find a common denominator between this fraction and this fraction. And if I do that, in this case, the common denominator is going to be 50. So really, this term right here, if I wanted to think about it this way, this term is the same thing as 2 pi divided by 50. So I'm going to go ahead and rewrite this term as 2 pi divided by 50. So guess what? If this term was a 2 pi over 50 and I took a 1 pi over 50 out of it, I would have a 2 left over. And you could always double check this by just redistributing this back in. Pi over 50 times x is pi over 50 times x. Pi over 50 times 2 is 2 pi divided by 50. So this looks good. So now I've got this thing. This matches up perfectly. A, here's my b value. Here's my minus h, except in this case it's a plus. We'll talk about what that means in a second. And then I've got my k value down here at the end. And now we can answer a ton of different questions about this particular graph. So let's go ahead and let's label some stuff first. Again, I promise the numbers are going to work out a lot nicer on this one. Let's label some things. So remember I mentioned on the last one, normally the highest and lowest values that this graph would get to would be 7 and negative 7. However, everything here gets shifted down 3. So the highest is usually 7, but it gets shifted down 3. Now the highest that we go is 4. If the lowest that we usually go is negative 7, but we get shifted down 3, now the lowest we go is negative 10. If the middle of the graph is normally at 0, but it gets shifted down 3, the new middle of this graph is at negative 3. Okay, and I'm going to put a dashed line in the middle here for the middle of the graph. Okay, now this one's a little weird because guess what? We've got a plus 2 here. Remember, if I have a plus on the inside, this shifts me left 2. So the only other thing I'm going to do before I start doing some calculations is I'm going to put a little mark right off here to the left, and I'm going to label that negative 2, because what this means is my graph got shifted to the left, negative 2. So instead of starting at 0, I'm going to start 2 to the left of that, which would be at negative 2. From here, I can start doing some calculations. So let's try it. The length of a period would be 2 pi divided by pi over 50. So let's try some calculations. 2 pi times, when I divide by a fraction, it's the same as multiplying by the reciprocal. When I'm done here, 2 times 50 is 100. Okay, so let's do a little bit of math here, some thinking. If I start at -2 and my period has a length of 100, number one mistake is students are going to come over here and they're going to put a 100. But that doesn't make sense because that means the length of the period would actually be 102 because I'm starting at -2 and ending at 100. Now, that's wrong because we just found the length of the period to be 100. So instead of ending at 100, we're going to end at -2 plus 100, which is a value of 98. So this mark over here is going to be 98. Now let's cut this thing into 4 equal pieces. Cut it in half once, cut both of those in half. And now we can figure out the length of each piece of this period. Okay, so remember the math for this. If the length of the period is 100 and I'm cutting it into 4 pieces, I need to find 1/4 of 100. Well, 100 times 1/4 is 25. So what I'm going to do here is I'm going to start at -2, and to get to the next piece, I'm just going to keep adding 25. Huge mistake I see people make, and you'll see I'm very repetitive with this stuff on purpose because students just make the same mistakes over and over and over again, no matter how many times I mention it. So I'll keep trying to mention it as much as possible. They'll put 25 right here. That's wrong because we didn't start at 0. We started at -2. So if I start at -2 and I add 25, I get 23. And then if I add 25 again, I get 48. And if I add 25 again, I get 73. And then if I add 25 one more time, 73 plus 25 is 98. So that seems to check out right there. So I've got everything labeled. Last but not least, I'm going to actually draw my graph. So this is a cosine graph, which either means it has to start at the top and go like this, or it has to start at the bottom and go like this. In this case, since it's positive, it's going to start up at the top. So I'm going to start at an x value of -2 and a y value of 4. Okay. And then from here, I'm going to go from the middle, from the top to the middle. So here's my middle at 23, -3. Down to the bottom at 48, -10. Back to the middle at 73, -3. And I finish back up at the top. You always finish where you started. In this case at 98, 4. And I'm going to go ahead and connect all of these points. And don't forget to put arrows on the ends because this is a wave. So we're only looking at one period of this wave here. But it actually goes on continuously from -infinity to +infinity. All right, we're going to talk more about this stuff when I see you guys again for our block period. But these are 2 good examples to get us started. Hopefully this is making sense. You're paying attention, you're writing some things down, and you'll be ready to rock and roll when we get in for our block period. Bye, guys.